Yeah, I missed
Okay.
that one day from.
Okay, guys. Lesson 2. More differentiation. Okay. Officially, I feel like a lot of this is going to seem familiar to you. Okay. It's one of those where I don't necessarily feel like, it's totally different. I feel like a lot of it is what we've already been doing, except we're more working with the charts this lesson. We didn't have as much in the way of charts last lesson, did we? We had a little bit, but not much. So here we're really working with the charts. So first of all, selecting procedures for calculating derivatives. There'll be times when you need to find an approximation of the derivative. Typically, this is the type of question will be given in the form of a table of values without a specific function. Okay. If we're trying to find certain derivatives, we have to use the values we're provided. And so thus it is an approximation. You'll need to identify an appropriate mathematical rule or procedure based on the given data to proceed successfully. So, for example, this table gives the value of the function, the values of a function that is differentiable on the interval from 0 to 1. Find f prime of 0 tenths. Or 0 tenths. What? Of 1 tenth. Now, for the record, it's a good place to point out, I see the word differentiable. What does differentiable imply? Continuity. So, because I know this function is differentiable, for the record, I also know it's continuous. Not that it really makes a big deal in this problem, but it's something I want you to think about. Okay, when you see that word differentiable, your brain can say, oh, I know it's continuous. Okay. Thoughts on how to find f prime of 1 tenth? Pretty much slope, right? Officially, I'm going to use the phrasing average rate of change. But when we talk average rate of change, we're pretty much talking slope. When we talk about average rate of change here, we've seen kind of 2 different ways to do it, because often we'll talk about using the values on either side of it, right? We don't have the values on either side of it, do we? And so in this case, then we're going to have to use the given value and the next closest value. Okay, so we will be using those values. I happened upon a discussion, can't remember if it was on the AP Calc Facebook page or the Flamingo Math Facebook page, which is this publisher here. But it was interesting because people were discussing, arguing that fact of when you have to use the number and when you pick numbers around it. So, okay, set it up. F prime of 1 tenth. If we do y minus y over x minus x, 0.433 minus 0.261 over 0.2 minus 0.1, whatever that math works out to be. I pulled from my notes. The numerator works out to be 172 thousandths, 0.172. Denominator obviously is 1 tenth. So 0.172 divided by 0.1 is going to be 1.72. Okay. So again, using the given information. What are my options here? Okay. Okay, example 2 if you're ready. Okay, symbolic differentiation. Given the table of values, find each of the derivatives of the following at x equals 2. Okay, so each of these we're finding the derivative, and then we're evaluating it at 2. So, in order to find, and I tend to put the 2 in later. You could go ahead and put the 2 in if you wanted. It depends on the situation. Sometimes that's not a bad idea. Sometimes it does make it confusing. So I'm going to wait. Not saying that that's what you'll see, you know, sometimes in the answer key you do see them going ahead and putting the value in. So how do we do the derivative of f of g of x? Okay. So this is chain rule, yes? This is derivative of a composition. So f prime of g of x, so derivative of the outside, keep the inside, times derivative of the inside. Now, we're actually being asked to evaluate this at 2. So we're doing h prime of 2, which is f prime of g of 2 times g prime of 2. How do I do f prime of g of 2? Find g of 2 first, yes? G of 2 is 3. So that means I'm going to have f prime of 3, which I'll come back and do in a moment, times g prime of 2. Negative 1. So then you're doing f prime of 3 which I just wrote down as negative 2 times the negative 1 we already had, which makes it 2. Is it just me, or have we already done stuff similar to that? I feel like. I don't feel like I really did anything just new right there. Good review then? Okay. B. K of x is f of x raised to the third power. Let's talk about k prime of x. How do we do the derivative of something raised to the third? 3 out front times f of x raised to the power of 2 times f prime of x. I feel like that might be a little bit newer, but it's the same idea, isn't it? So derivative of something raised to the third is 3 times that something raised to the second times the derivative of something, so times f prime of x. Now, of course, we're evaluating at 2. So k prime of 2 is 3 times f of 2 quantity squared times f prime of 2. 3 times f of 2 negative 4 squared times f prime of 2. 8. I see 3 times 16 times 8. What is 3 times 16 times 8? What was it? 384? Sounds familiar. My guide agrees. Okay. Continuing on, C. P of x is f of x times g of 2x. So what are we doing here? Product rule, yes. And realize also within the product rule there's going to be a small bit of chain rule in there. Okay. So derivative of one, keep the other. I tend to do derivative of the first. Honestly, I feel like every time I look at the answer key here, they tend to do the other way. So I don't care what you guys do. So derivative of one of them, I'm going to say f prime of x, keeping g of 2x. Product rule says we add And now, this time I'm going to keep f of x, derivative of g, so g prime of 2x, derivative of g of 2x, times the derivative of 2x, which is 2. This is a situation where, had you filled in the 2 to begin with, that would create a problem, because you would have lost this chain rule. You wouldn't have seen the chain rule, if that makes sense. And so this is a situation where I didn't fill in the 2. That's why I try to be consistent and not fill it in. So, p prime of 2. F prime of 2 times g of 2 times 2 is going to be 4 plus f of 2 times g prime of 2 times 2, so 4 times 2. Let's see, f prime of 2. 8. G of 4. 2. F of 2. Negative 4. G prime of 4. 3 times 2. I see 16 minus 24. Negative 8 if my mental math is right. So, there's a nice variety here, guys, because now what do we get to do on D? Quotient rule. Unless if you really wanted to, you could bring g of x up to the negative 1 power, but then you'd have product rule with chain rule in both pieces, and I don't think it makes it any easier in this case. So, r prime of x. Now, this one it matters, right? You have to have, when you do that first pair, it's derivative of the top, keep the bottom, right? So, derivative of the top is f prime of 2x. When we do derivative of f prime of 2x, that's going to have to be a chain rule, so times 2, right? And then keeping the bottom, g of x. Quotient rule says minus. Now I'm going to keep f of 2x, and I'm multiplied by the derivative of the denominator, which is g prime of x, all over g of x quantity squared.
So, how do we know to take the derivative of the 2x? Oh, wait, yeah.
Because it's chain rule.
Yeah, I'm confused. Like I know you explained it earlier, but I'm just like, how to know if we keep going.
Well, it's always technically we can always apply the chain rule. And so the derivative of the inside is 2x, or the inside is 2x, the derivative of 2x is 2. That is the only inside there. When we do the derivative of 2x and get 2, there's not another inside. It's more when you have pieces within pieces. Like we have things within cosines, within natural logs that we want to keep, that we might have to keep going. When you're down to just a terms, individual terms, or polynomial type, where it's a term plus a term plus a term, you just do the derivative once and you're done.
So it's not necessarily
What?
It's not necessary to limit it's multiplication. Just keep going on figuring it.
I'm not quite sure how to respond there, so. Okay, if you haven't already, fill in your 2, yes? Although I'm going to run out of room on this one. F prime of 2, or R prime of 2 is going to be F prime of 2 times 2, 4, times the 2 already there, times G of 2, minus F of 2 times 2, so that's F of 4, times g prime of 4. Nope. See, I got caught up in the 4s. This is just g prime of x, so g prime of 2 all over g of 2 quantity squared. Okay. F prime of 4 is -1 times 2 times g of 2, which is 3, minus f of 4, which is 0, times g prime of 2. Does it really matter what g prime of 2 is? Not really. All over g of 2 squared, which is 3 squared. So what do I have? -6 over 9. So -2/3. Sorry, I'm not going to try and write down that corner. It's not happening. And that's because 0 times -1 went away. Okay, questions on that front page? That was the better page. This next page is interesting. A little challenging in spots. Next page, the difference is here they give me a nice chart, yes? I actually kind of enjoyed the chart because now they give us a graph. Okay, so note on the graph, what do we have here? The pointy one is F. The curvy one is G, right? You have to know which graph is which. You have to be very careful. H of x is defined to be f of g of x. So that is defined up here, where the graphs of f and g are shown. Estimate each derivative. Justify your analysis algebraically. Key word there, guys. I cannot stress this enough. Estimate. Most of them will be fairly obvious, and it's not so much estimation as just looking at the graph. There are a few where we really do have to estimate. And I feel like on an actual AP Calc exam, you wouldn't have, they would definitely be precise answers, okay? Even though we're officially estimating, I feel like it'd be more exact. Okay, G prime of 3. Thoughts on G prime of 3? So G is my curvy graph. There's where the point G of 3 is. Is that what they asked me for, though? We need the slope of the tangent line at that point. Okay? So this goes back to first chapter, first unit, where you guys, you're drawing in that tangent line estimated, okay? Again, I don't feel like you see that so much on AP, but we're trying to draw in a tangent line. Obviously, I can use this 0.35, yes? Well, I say obviously. In my brain, it's obvious. Or that's close enough to 3.5, I'm going to call it there. And then we want to draw a tangent. It's going to go something like this. And then it's also going to end up going through another point. Okay. That's my tangent line. I'm going to go with good enough as is. The way I drew mine, I also end up in the ballpark of the point 5, 4. Okay, so if we want G prime of 3, we're doing the slope at 3, y minus y over x minus x So slope is negative 1/2. Okay. F prime of g of 3. Realize they already have the value plugged in for us, don't they? Okay. Because they already have the value plugged in, this is more of just an evaluate. It's not saying find the derivative. Or not saying find what f prime is or whatever. This is what we're finding. We're finding f prime of g of 3. So don't try and do the derivative and chain rule or anything like that. Just evaluate is more what this is saying. Okay, the derivative is already done. So if we evaluate, of course, where do we start? We start with g of 3, yes. What is g of 3? Is that one we just talked about? Yeah, that's the one where I would say that g of 3 is 5. So then we're doing f prime of 5. What about f prime of 5? Non-differentiable. We've got a sharp corner, yes? And so what do we know about f prime of 5? Does not exist. Okay? And we're going to say I'm going to write non-differentiable due to sharp corner. Okay. Easy enough there? Okay, C. Now, unfortunately, we're going to have to just go back and forth. You guys have the graph in front of you, right? There's no way I was going to be able to write in those boxes if I put everything on one screen. It wasn't happening. I'd rather bounce back and forth. So h prime of 3. Well, this is where you have to go back and think. What was h of x defined as? Yeah. H of x is defined as f of g of x. So how do I define the derivative of h of x? We're going to have to do derivative of the outside times derivative of the inside. So because this is, h is defined to be this f of g of x, in order to find the derivative at 3, we have to find the derivative of h. And so then we can do h prime of 3, so f prime of g of 3 times g prime of 3. G of 3, that's one we already talked about. Yes? G of 3 is 5, yes? So f prime of 5. The next part is where, yeah. G prime of 3, could we do G prime of 3? Didn't we already do G prime of 3? That's our answer for part A, yes. But what happens when we go on to the next step? Yeah. We just talked about in the last part the f prime of 5. That's that hard corner does not exist. And so if f prime of 5 does not exist, then we're going to have to say that h prime of 3 does not exist. Thoughts on f prime of 7? F is my pointy function, right? F of 7 is right here. What are your thoughts on f prime of 7? What? Ah, I was like, where are you getting?
2.
Yeah. Okay, so can we just think rise of a run here? Yes? Or we can go down this way if you prefer. Which, I would just think rise of a run here. When I have a graph, I'd much prefer to do rise of a run if I can, as opposed to writing out my ordered pairs. So if we rise 1, run left 2, or rise -1 and run right 2, one way or another, you end up with -1/2. Okay, so we can talk about it being the change in y over the change in x, or if we go back to our algebra roots, it's rise over run, right? But we end up with -1/2 one way or another. Okay, E, G prime of f of 7. Again, you're just being asked to evaluate here. It's not saying, that we have to worry about anything else. We're just being asked to evaluate here. So, G prime of f of 7. What is f of 7? I don't think we've done that, have we? F? Oh, wait, that's what we just did, isn't it? Right? Yeah. No.
We did f prime of 7, not f of 7.
Oh, we did f prime of 7. Okay, got it. Sorry. What is f of 7? That has a value of 5. Got it. Sorry, this whole flipping back and forth is going to get me here. So f of 7 is 5. Got it. So now I'm doing G prime of 5, right? What about G prime of 5? G is my curvy. Where's 5 at? Okay, I need some of this. Need some of this extra stuff gone. Sorry, it was going to be too much for me. Okay. Remember your directions were to estimate, yes? This is where it truly comes in, because we can't really do anything about it. It is estimating. So if we want to know wrong way. What am I doing again? G prime of 5. Got it. The slope of 5. Slope of G at 5. At what point does this look like this is at? Does that look like 5, 3.5? Could we use that as a point? We can. Okay. Now, to get the slope, we're obviously going to have to draw our tangent line and hit another point along the way. Okay. There's my tangent line. Notice because of the angle, it's running along there quite a bit. So 3.5, 5. I ended up with something at 7.2. Looks like you could also say 3.5 maybe. I just changed that page and maybe I shouldn't have. So I'm going to say we had the points 3.5, no, 5 3.5. Goodness, I can't. 5 3.5 being the starting point, and then 7 2. In all honesty, though, if I went over and used that, what did I say it was, like 3 5, then I avoid the decimals. But here I'm at least making sure I use a point that is on the line. So 3.5 minus 2 over 5 minus 7. 1.5 divided by negative 2. And if I take 1.5 and divide it in half, I'm going to be at 3/4. Positive divided by negative is a negative 3/4. I just looked at what's 1.5, and when I take half of it, it's 0.75 or 3/4. So negative 3/4. Okay. H prime of 7. We've got to go back to what H was, yes? And we already talked earlier. Can I just use what I have over there? We already talked that H prime is F prime of G of X times G prime of X, yes? Can I go ahead and put 7 in there? F prime of G of 7 times G prime of 7. And that is from what I did on part C. Okay. G of 7. I think this is an estimating one if I recall. G is my curvy one of 7.
Judges, please pardon the interruption. Attention all middle school and high school teachers. IT is going to be restarting the middle school high school server. So if you are working in that server at this time, please save your work. And it should be back up by 12:38. Again, all middle school and high school teachers, IT is going to restart the middle school and high school server. So be sure to save anything you're working on, and it should be back up by 12:38. Thank you.
Will you lose your recording?
No. Because it just saves to the bin queue, and then I upload it. So, and then honestly, I upload it to OneDrive, so that when it's the server for the in computing is what it is. So, okay. While Jen was talking, G of 7. It's not a nice even number, is it? I used 2.8. Could we guesstimate it either way from there? Yeah, I don't, it is what it is. Not my favorite example here, but we're going to do it. So that's going to become F prime of 2.8. G prime of 7. Have we done G prime of 7 yet? And G prime of 7. Oh, that's fun. That's right there at that point also, isn't it? So G prime of 7. How did I end up doing this? I know where I ended up going through when I drew this with my ruler. I ended up going through 8 3 and 1 1 when I drew this with my ruler on my paper. I'm never going to be able to make that happen here. Well, I'm still going to use 8 3 and 1 1 because I can't draw on this bin queue. I just can't. I can't get a straight line exactly where I want it. Obviously, this is estimating. If your numbers were slightly different, would that be okay? Yes, it would be, right? So don't let that stress you. So if I use 1 1 and 8 3 to do my slope, then that means I'm doing 3 minus 1 over 8 minus 1, which on my next step is going to become 2/7, right? Then we have to go back and do F prime of 2.8. F prime Oh, F takes me to the sharp one, pointy one. F prime of 2.8. Well, this makes it easier at least. That's on that negative sloped line, isn't it? So what's the slope here? Rise 2, run 1. Rise 2, run 1. Run negative 1. So that slope is negative 2. Negative 2 times 2/7. Negative 4/7. Okay.
I kind of like this.
I will say, let's see. Yeah, there wasn't nearly as much. It's mostly charts in the homework, not so much the graphs. So, okay, guys. Weird to say, that means this homework is due tomorrow, right?
That's crazy.
Okay. So, I know we've gotten in this habit of notes taking 2 days, and I don't like, the notes are usually long. I get it, but on occasion, we're gonna get through them in one day, and we did today. So.